So far, we have talked about the scheduling algorithms for processes. There, we either do not consider the thread or we assuming no thread. So now let's look at the thread scheduling. We need to distinguish whether we are dealing with user level threads or kernel level threads. So when kernel level thread is supported, so we just schedule the thread onto the CPU instead of scheduling a process. We can use the scheduling algorithm we have learned in the previous slides to schedule those kernel level threads. This policy is known as the System Contention Scope, which is shorted as SCS. So in this scope, the competition is among kernel level threads instead of processes. On the other hand, when the threads we are dealing with are user level thread, they are scheduled by thread library and run on lightweight process. We use LWP to represent it. Those user level threads can be run on LWP either through many-to-one or many-to-many model, as we already mentioned in the previous chapter, so that those threads can be mapped into different CPUs or different processes. And we refer this mechanism as a process contention scope, and shorted as a PCS. So usually those user level threads within a single process can be scheduled with a priority scheduling algorithm, and the priority of each thread is assigned by the programmer who creates those threads. Now let's look at how to use the Pthread library to deal with thread scheduling. As we already mentioned that Pthread can be implemented either as a kernel threads or a user thread based on the operating system, so that Pthread provides API that allow specifying either PCS or SCS during thread creation. So basically, we can use a constant Pthread scope process to schedule threads using PCS scheduling. And also, we can use another constant Pthread scope system to schedule threads using SCS scheduling. Remember, we have mentioned that how the Pthread behaves depends on the operating system who implemented. In Linux and Mac OS X, their Pthread library only support Pthread scope system. Now let's look at an example how to use a Pthread library to implement thread scheduling. In this code, we first declare a Pthread attribute variable attr. Then we use a Pthread attribute init function to initialize the attribute variable. After that, we use a Pthread attr get scope function to get the scope value and store the value into integer variable scope. And then further check whether this scope is a Pthread scope process or a Pthread scope system. Otherwise, something wrong must be happened. And then we use a Pthread attr set scope function to set the Pthread attribute to Pthread scope system. Then you can use the attribute you just set to create threads. And the newly created threads can be scheduled by Pthread scope system in this example. And also remember that in Linux and Mac OS X system, they only support Pthread scope system, which use SCS scheduling. So you can not use others. You can play this code on your computer or on the virtual machine to see what the output looks like.